Good evening. Myself Dr.A.Vaniprabha, Associate Professor, ECE Department, working in SNS College of Engineering. In continuation of the previous session, today we are going to discuss on path loss. What is path loss actually? Path loss in wireless communication refers to the attenuation or reduction in the signal strength as the radio wave propagates from transmitter to the receiver. It is a fundamental phenomena caused by various factors including distance, obstacles and environmental conditions. Understanding and quantifying path loss is crucial for designing efficient and reliable wireless communication systems. There are several factors contributing to path loss. Distance, free space loss, obstacles and penetration loss, multipath fading, atmospheric attenuation, antenna characteristics, etc. Understanding and accurately modeling path loss is essential for designing wireless communication systems with adequate coverage capacity and reliability. Engineers use various propagation models and simulation tools to predict and mitigate the path loss effects during system design phase. Additionally, techniques such as diversity combining, power control, and adaptive modulation are employed to mitigate the impact of path loss in deployed systems. What is large scale path loss? Path loss, particularly large scale path loss, is critical concept in wireless communication. It refers to the attenuation or reduction in signal strength as a radio wave propagation through the medium such as air or free space. Large scale path loss is primarily influenced by the distance between the transmitter and receiver, as well as the environmental factors like terrain, obstacles, and atmospheric conditions. Several models are used to characterize large scale path loss, with the most common being the free space path loss and the two-ray ground reflection model. The mobile radio channel places fundamental limitations on the performance of a wireless communication system. The wireless communication or transmission path may be line of sight or non line of sight. Radio channels are random and time varying. Modeling radio channels have been one of the difficult part of mobile radio design and is done in statistical manner. When the electrons move, they create electromagnetic waves that can propagate through space. By using antenna, we can transmit the electromagnetic signal and receive the electromagnetic signal. Like microwave, infravisible, and radio waves can be used. There are certain properties of radio waves that dominates the propagation of electromagnetic waves. They are easy to generate, can travel long distances, can penetrate buildings, may be used for both indoor and outdoor carriage, and are omnidirectional and can travel in all directions. Can be narrowly focused at high frequencies using a parabolic antenna. Right. Frequency dependence is one of the factor to be considered. That is, it behave more like light at high frequencies, difficult in passing the obstacle, follow the direct paths, and it is easily absorbed by rain. And also behaves more like radio at low frequencies. The EM waves at high frequencies behave like light, and at low frequencies behave more like radio waves. It can pass through the obstacles. Power falls off sharply with distance from the source. Subject to interference from other radio waves. The statistical modeling is usually done based on data measurements made specially for the specified communication system and for within the given spectrum. There are many tools that is used for predicting the average signal strength at a given distance from the transmitter. Estimating the variability of the signal strength in close spatial proximity to a particular locations. Propagation models. Large scale propagation model. What is large scale propagation model? So this kind of propagation or model is analyzed so as to predict the mean signal strength for an arbitrary transmitter receiver separation. Estimate radio coverage of a transmitter, characterize the signal strength over the transmitter receiver separation distance of hundreds to 1000 meters. Propagation models like small scale or fading models characterize rapid fluctuations of the received signal strength over very short travel distances, a few wavelengths, short time duration on the order of few seconds. So this is a simple pictorial representation of small scale and large scale fading. So the small scale fading experiences rapid fluctuations, whereas the large scale fading have a stable, almost even distribution through the distance. The spikes belongs to the small scale fading. Thank you.